Welcome to this brief tutorial that accompanies the Quick Start Guide to Classification of Stellar Spectra. This tutorial will walk you through the introduction and then part A of the actual lab. The first thing you're going to want to do is get to the CLIA program. Remember, CLIA is a program where a lot of data has been stored and allows us to access it quickly. In this particular case, we're going to be using the Virtual Observatory, Vireo Virtual Observatory. So you'll need to log in. It's always important when you log in to log in exactly the same way. So we'll log in as Joe Schmo. In this case, a folder will be made in CLIA and that data will fall into the folder. As long as you log in with the same username, you should be able to access your data if you do have to leave the program. We finished logging in. In this particular program, we're running the exercise, we'll display that, classification of stellar spectra. That window will pop up. Number of things you need to do. We're first going to just learn in part A how to identify stellar spectra. So in this case, we're going to do the spectral classification tool. Spectral classification tool. We'll load in some data, so we'll go File, Atlas of Standard Spectra. We'll choose the main sequence. You might remember that somewhere between 80 and 90% of the stars that are visible in our Milky Way are main sequence stars. Double click on that, and the top and bottom will be a small sample, only a relatively small portion of the entire spectrum, but this will give us enough to be able to classify the stars. We're going to go from O to B. Here it is. O is on top. B0 is the next one. If I move down one, say to B0, notice that they change. So each time they change. And you can use the arrow, up and down arrow buttons on your computer to change which class stellar spectra you'll be looking at. Now we're going to want to call in some different spectra, and this will be the unknown spectra, and there'll be a program list, and your lab will ask you to pick a variety of different spectra. We'll just pick the very first one, and there we go. So the question is, which one does this most look like? I think I'm getting closer to it, and now I'm probably getting farther away from it. That's one way of doing it. So it looks to me to be somewhere between an A5 main sequence. Remember, the Roman numeral V at the end stands for main sequence, and an F0. Now to help you out, we're going to do this. We're going to do display. Now keep in mind, back in the day, they would actually have to look at the actual photographs to try to determine the spectral type. With computers, it's a much easier proposition. So we're going to display intensity trace, but we're also going to display show difference. What this is going to do is change the window slightly. So the bottom is actually going to show the difference between the two. So it's this curve minus this curve. And you can see that's very nearly a straight line. I'm going to go down one more. Clearly it's worse. I'll go up one. That seems better, and that seems worse again. So it seems to be pretty close between an A1 and an A5. If you look at look at this particular absorption spectral line right here, and you notice, watch how it drops. There I think it's too small. Here I think it's too big. Too small, too big compared to this one, which leads me to believe that this particular star is neither an A1 nor an A5, but instead an A3. We don't list all of the options here because you'd have to scroll through O, B, A, F, G, K, M. That's 7 times 10 numeric separations for each. And that, of course, would be 70 different combinations. So we're going to figure it's between an A1 and an A5. We call that interpolation to read between values. A1, A5, we'll go with an A3.